positive is counterclockwise, and a negative number is clockwise. So if I come around like that, that's negative. If I come around like this, it's positive. So that's a positive. So we're going to go this direction.
Oh, you're rotating. Oh.
So if we're going to rotate it,
Yeah.
if we're going to rotate it 60 degrees,
I thought you meant it was rotating that way towards the 60
Oh.
degree dot, but
no. So this is going to be the center of rotation, right here. So that means, like, if you took a string out here and you went around, along that arc is where P has to fall. So if I just use this drawing compass, let's see how good this works. And I draw an arc like this. It's around this arc. Oh. It's along that arc that P is going to end up, no matter what. It's just a matter of how many degrees are you going to travel to get to where P is going to land. So if I was to then draw a segment here, and then I came in with my protractor and marked off where 60 degrees was, and drew a segment like that, this location here is where P prime is. So this is the 60 degree turn. But when you do those for a triangle, like maybe we've got a triangle now that's like this, P, Q, R. Now Q has to do the same thing. It's going to have to go 60 degrees. But your 60 degree angle has to be drawn up again. So there, that's 0 degrees. Now we have to move it along an imaginary arc out here. So this is 60 degrees from this direction. So you take a drawing compass, you measure all the way out. This is about where you're going to end up. Now there's lots of lines in there, aren't there? And that gets complicated to keep an eye on. So I would suggest you draw your angles really light when you do this in the future. And draw your arcs, draw everything as light as you can with the exception of, you know, what you're calling your triangle here. This needs to be nice and dark. There it would be. Then down here is where we would have Q prime. Once you get your 3 points down here and labeled, then connect to them. So this segment here becomes this segment, and then when R comes, it's going to form a triangle out in that direction. Okay, so these got pretty tough. Looks like a lot of you did well, or you got a really good start with these. So let's take a look at this. There was some uncertainty over. And the value of n. So when we talk n-fold rotation symmetry towards the end of the hour Friday, n refers to the number of steps that you have to take to rotate an object around and get it to become the same, here, let me do this. I have different colored magnets. Maybe this one. So I've got a blue one and an orange one. If you look them in the Walter Mitty movie. Blue car and a red car. There you go. There's blue and So if you think of this pentagon here as the original image, and then we take our blue one, and I turn the blue one until it lands on top of the red one. How many times do we turn it before we get the starting point back to the beginning? 5 steps. So this has 5-fold rotation symmetry. It takes 5 partial turns to get back to where we started. This here, on the other hand, how many times can we turn this object to get it back upon itself? 3 times. So this has 3-fold rotation symmetry. So if you had a quadrilateral, how many times would you turn it?
Should be 180.
And it's so, for example, the square. If I took a square, how many folds is this? That's 4. Because it'd be 4 turns to get back to where you started. But quadrilateral, what's the definition of a quadrilateral?
3 equal sides.
There's 4 sides. Okay, so help me out. Is that a quadrilateral?
No.
Yes.
No.
Does it have 4 sides?
Yes.
Are all of the...
Not equal though.
No, they're not equal. Well, if this right here, is this a quadrilateral?
Yes.
What kind of a quadrilateral?
Square.
A square. Is a trapezoid a quadrilateral? It has 4 sides, 2 of which are parallel to one another. So this is a quadrilateral. How many fold symmetry does that have?
No.
If this is the center, how?
0.
It's got to go all the way around, doesn't it? Yeah, 1. 1 time all the way around, and that's it. There's no folds to it. So we don't, generally something like that, we say that its rotation symmetry is that it can only rotate 360 degrees. Yes?
Wait, so the aspect for quadrilateral, that could be like a lot of different things, so how are we supposed to know?
Well, you have to take it as the least restrictive as possible. So if you said 4, you were thinking of a quadrilateral being a square. If you, here, if I put these 2 together, does that make a quadrilateral?
Yeah.
What's another name for that shape?
Rectangle.
It's a rectangle. So is rectangle on here? Ah, yes. So that rectangle, how many? 2, that's 2-fold. So a rectangle is 2. But a quadrilateral, we can't say, because a quadrilateral doesn't have any restrictions other than that it has 4 sides. So we aren't going to say anything more than 1. I don't know, it's a little
We
tricky.
just write 1 through 4.
How about a parallelogram? You're saying that you can't rotate it a part of a turn? So if I made this my parallelogram, is a square a parallelogram?
Yes.
Is a rectangle? Is this? Yeah, but this object here,
The sides never touch.
I mean, if you turn it, does that look the same?
Yeah.
So you can turn it 180 degrees and then 360. So that's 2 folds.
Wait, what if it's like not that shaped?
Okay, well, if it's a parallelogram, you need to have 2 pairs of parallel sides. So this is a parallelogram. This is a parallelogram. I'm sorry, I don't have any that are magnetic. That's a parallelogram. Oh, here. This is a parallelogram, yes?
Yeah.
Yeah, because you got, those two sides are parallel, and the top and the bottom are parallel. So this, if I turn it 2 times, I'm back to where I started. And each step of the way, it landed back upon itself. Here, I'm gonna just draw this, like so. So if we turn this, keep it all together, it fits again, yes? All right, so there's once, and now twice we're back to where we start. So that's 2 folds to get back to 360. This rectangle, here's your rectangle. The blue's on the left, once, twice. A rectangle also has 2-fold rotational symmetry. Oh, yeah.
Why don't you turn it like, if it's like this length, right? Why not turn it this way? Like, why can't that come up?
Like this?
Yeah, and then that would be 1, and then the next one 2, and then something. But like, because it's a flat edge, it's like
Okay.
this, I guess.
So why can't we just turn it that way? Question or answer? You had your hand up. Okay, so why, does anybody know why we can't do this?
Well, no, like, turn it like that. That's one of the right figures.
Okay, so here's the figure. Why can we not say 1, 2, 3, 4? Why is that?
It's not the same all around.
What's not the same?
The shape, it gets long and short.
Oh, so the long and the short sides change.
But why can it not?
Oh, yeah, it's still the same shape. I mean, this one here, I could turn it 1 degree and it would still be the same shape. However, it has to, I mean, if this leaves a footprint, maybe we can think of it that way. If this rectangle leaves this black footprint, I have to turn it 180 degrees before it fits into the footprint again.
Okay, so only one rotation, counts as it okay.
So I start here, I fit back in the footprint 1 time, 2 times to get back to where I started.
Why would it really start?
I'm sorry?
Why would, if you went back to where you started, why would that count?
Why would it count if you go back to where it started? The arithmetic is easier. I guess it's, this shape here can only turn 1 time to land back upon itself. So it has 1 fold. There wouldn't be anything that we would say would have 0 folds. I know the fold is kind of a misleading, but it's a term that refers to landing back upon itself.
What would trapezoid be?
We'll go there in a second.
Wait, so there's not like one answer for the square, it's different too.
The square is different too, isn't it?
Yeah, so then how would you like know the right answer if there's a couple different?
For quadrilateral?
How do you know it's the right answer? That's a good question.
Wait, isn't a square just 4?
Yeah, a square is 4.
But I thought the parallelogram,
And a
other
quadrilateral.
parallelograms have 2.
Yeah, this is more specific than a parallelogram, isn't it? And this is also more specific than a parallelogram. So if they say parallelogram, we can't assume that it's anything more than just 2 pairs of parallel sides. If we say, they say a quadrilateral, all we can say is it has 4 sides. I'd like you to look at the progression of this. So when they say a quadrilateral, I'm going to do this over here again. Is this a quadrilateral?
Yes.
Okay, sweet. And when they say parallelogram, looks like this. It still has four sides though, yes? Okay. Now we go a little further, a rhombus. How do we define a rhombus?
Like a little kite.
Is it a kite?
No, diamond.
More of like a diamond shape, yeah. This here, that's a kite. That's, we're not talking kites. This could be a kite. But, but if, I'm sorry?
That is a kite. It's just a kite inside.
Oh.
Yeah, well, maybe, but it's, this is by rule, that's not even a kite either, because isn't a kite symmetric?
No.
Well, but it's different.
Geometry they are. Come back in 4 years, okay? They are, or 2 years. Kites are symmetric, but we're leaving kites out. Kites get complicated, but like this, could that be thought of as a rhombus?
Yeah.
It has two pairs of parallel sides, and all sides are the same length with a rhombus. So it's like a square that gets squished down.
So it could be a quadrilateral. But it is a
It is a quadrilateral, and it's also a parallelogram, because it has two pairs of parallel sides. Now take this, or this shape, I guess you could take this shape and turn it into a, ooh, I'm skipping one, trapezoid, right? Okay, trapezoid has how many sides? 4. How many pairs of parallel sides? 1. So, it could be like this, if these two sides are parallel. You gotta rotate it the whole time. It could also be kind of like this, really symmetric, right? Where this angle and this angle are the same, that angle and that angle are the same, these sides are parallel.
Isn't a square a trapezoid?
A square is a trapezoid, because a trapezoid has to have at least one pair of parallel sides. So if you took this, I can make that out of magnets, I think. Really close. I can't. Let me think. No, here, here's a trapezoid. That's an isosceles trapezoid because it's symmetric. But even this trapezoid, how far do you have to get it before it has this same footprint? I mean, you gotta go all the way, don't you?
Yes.
So there's only one fold in a trapezoid. One fold, all the way around. But if it's a special trapezoid, like a rectangle, so now what we did is we got more specific. We said it has two pairs of parallel sides and 90-degree corners. So there's lots of restrictions with this, lots of rules to follow when you draw a rectangle. How many fold is this? Once, twice. How many folds with our square? 1, 2, 3, 4. So with a quadrilateral, it's one fold. With a parallelogram, it was 2. With a rhombus, it was 2. With a trapezoid, it's only 1. With a rectangle, it's 2. And a square is really, really specific. There's lots of rules to draw a square. All 4 sides must be the same size. You have to have 90-degree angles. And then you end up with 2 pairs of parallel lines. So the more restrictive something gets, potentially the more folds of symmetry. That's what the table was showing you. How many folds? 6. 6. How many folds?
Oh, wait.
What?
How many folds?
What's,
How many folds?
Six.
Five.
what's the measure of smallest turnaround?
Like rotation?
Once, 2, 3, 4, 5.
With
Okay.
polygons, it's just the amount of sides they have, so it's always equal.
So these are all regular, which means that they have all sides the same and all angles the same. So they're not like this kind of thing. And they're not even like a trapezoid. They're symmetric all the way around. So in this case here, if we look at the pentagon, here's the center of rotation when it goes around. And it can stop once, twice, 3, 4, 5 times. Probably gonna play with these since Mrs. D.
No, I'm doing science.
Dylan? Do you have Mrs. Dagan?
Yeah.
Are you her last?
No,
We're like,
third last. No, third to last.
it was,
Yeah, we had Mrs. Fagan.
If 6th graders
Okay. I'm gonna do this.
Oh, yeah, I know they did, because it's already after.
I'm gonna grab 2 trapezoids. No, yeah, 2 trapezoid, a hexagon, a rhombus, an equilateral triangle, and I don't have pentagons, do I? Come and grab one of each of those.
Oh, wait, no, can you leave those just so that everyone knows? I dropped it! Thank you. Need these. You can still do a hexagon on the hexagon, right? If you take the bottom off?
Yeah.
Do you want 2 trapezoids or just 1? Yeah, he said 2 trapezoids. So 2 trapezoids? Okay.
Yeah,
2 reds.
2 trapezoids.
This is what you need, 2 trapezoids, hexagons, a rhombus, and an equilateral triangle. You get it?
We'll start with a pentagon.
that was really drawn out. Looked at it.
So we're switching gears.
This is what you need, what's in my hand? That is not in my hand.
All right, you have a straight edge. So there's some pentagons out there. You're gonna have to share the pentagons. I only have so many. And what I'd like you to do with your pentagon,
Whoa.
I don't know if a straight edge works, or maybe if you go along the edge of the pentagon, but don't go around the corners. I'd like to get you guys started together with this so we can't have sidebars. So take your pentagon and then share it. And don't go around the corners of the pentagon. Don't create the vertices because they'll be rounded. We don't want them rounded. And if you you do what I just did here, where I went along the straight sides of that pentagon, then come along with your straight edge and extend those.
Is this in the notebook?
What's that?
Is this in our notebook?
Yeah, on your homework note, or your notes notebook is fine. And if you do that, then you'll create nice vertices, nice corners to your pentagon. And if you want to be really neat, you can back up and erase a little bit.
Are we going around the inside or the outside?
It won't matter. So now we're shifting gears a little bit. Draw your lines of symmetry. You need a straight edge. You need a protractor.
Getting all of the oxygen.
I don't know if I trust those things.
I knew it.
Okay, anybody having,
I already did this.
okay, so draw your lines of symmetry using a straight edge. Yeah, oh yeah. Ooh, this gets hard,
Once you
doesn't
have
it?
it drawn out, you're doing 1 through 4 for, you're going through 1 through 4 on the board. So 1 through 4, you have to do for all of the streets. So once you have it drawn, then you have to go through the numbers.
There's one line of symmetry. Imagine that line's not there, where else could you draw that line?
There were minimal amounts of pentagons, but I think you and Ariel are sharing a pentagon, so I think you're fine.
So you can ignore the line you drew. So you rule out that line.
On the middle.
No, I'm not gonna do for symmetry. Put it up on your side. There you go.
Where all the lines of symmetry is, you said.
Should've thought about that.
There you go. All right,
Why do you extend that?
so then you can put a protractor on it.
They're all the same angle.
Well, good. You got that.
Oh, so you don't.
What are they though?
You don't have to extend all of them.
I did something wrong.
Remember the lines can be cut it equally. So if you were to fold it at the line, then it'd be the same.
In words, where did they intersect? There you go.
72 each one. 70? Well, I'm saying it's not 70.
So you need a longer, you need like your ruler or one of those triangles or something so that you can be nice and long. It needs to be here. Otherwise you're gonna have a hard time with it. So you might then use the edge of the book or something. You need nice long lines of symmetry, not just from the center out. But you see how I cut mine all the way across? Then you cut this thing in half. So you have two reflective atoms.
Is this right?
So where do they appear across? The center point. Okay, so this will be the minus 1. And this one.
I'm not gonna tell you, I always say. I'm not gonna.
I just realized you do 40.
I'm not right, it's gonna be the same on both sides.
So
Half
you
of
come in.
I'm gonna fold it on the line.
Oh, that's good.
I don't know when I see them. But there are like 5 or 6 of them in there.
There's 5.
Yeah.
I see 5.
There's one, but visually, I also.
Yeah.
How many degrees is that? About. Measure a couple of them and see if they all come up to 30. How we done?
Measure it from each one. Take it all by down. Each corner.
You do the pencil line? You're gonna end up with the same.
Wanted to know, this is the one that I was working on the board with you guys for now. So I think we want to do this one first. Let me go over the steps together.
I'm sure it takes that one, right?
That is,
Yeah, that's a,
yeah, that's a hexagon, that's probably why.
this is a hexagon.
Hexagon has 5 sides.
No, hexagon has 5 and a hexagon has 6.
Okay, so you draw lines of symmetry now?
Oh, yeah, hex is, yeah, hex is, which,
Use your ruler, you need to go the whole way.
I'm just
Now,
gonna
how
say.
can we bring that up to the flex that up?
how could you know? I don't know. How could you know?
Because I'm smart.
How could you know?
Good. If anybody has a hard time seeing the lines of reflection, anyone has a hard time seeing the lines of reflection?
Does anyone want 2 pencils? Let's see, we're for 3. Yes, I would take them.
I don't know why we have so many of them, we got like 40 of them. I think everyone's seen.
How many do you have? It splits it, it reflects it, so that you can see what you need for your fire, for your. You put it on the line.
Sure, why don't you come and grab one of these.
I can't see anything after it. That's one more line.
I know, that's why I'm giving you this to see.
I'll take it here. Pass them around. Turn around, just hand them over.
Fancy, schmancy.
These are, I can't remember what they're called.
I literally looked into it for 1 second, my eyes just were like. I have
There's a beveled edge, the beveled edge goes down. There's a sharp beveled edge to it, and it goes down. I think you have enough now.
Do you want mine? I'll just take it fine. It hurts his eyes.
This is on
I
mine.
get it anyways.
So if you lay this on your line of reflection, and then you look at, put beveled edge down. Go to the beveled edge. And then you look into your reflection of this. So
Wait,
here you see a
Shouldn't
reflection
they all go through the middle point?
on one side,
Right, yeah.
and it will, and it'll be a red line, and it'll lay itself on top of it. So then you can see exactly where your line of symmetry is. Not what we were planning on doing today. Okay.
There you go, yeah, from
The
the
last
side.
2 weeks I've been so choppy with these guys.
Got it. Here, let me look at yours.
I like the red, because the red makes it dark. The purple is a little lighter. Purple is really hard. Yeah, it's lighter.
Think about this, every point has to go through the middle.
So what these mirrors are used for is you can take a figure and you can reflect it over a line without doing what we were doing with the measuring and the 90-degree angles and everything. It's done at kind of an introductory level to looking at what reflections are all about. So I put it in front of you. You can see all of these lines that you put on this pentagon are lines of reflection. Where you have a left side and a right side, or above and below. So with that pentagon, how many lines of reflection? Phoenix, so how many lines of reflection? Yeah, I know everyone likes to do that, Hayden, up here. How many lines of reflection did you draw? How many are there? Here, I'm going to number mine. 1, 2, 3, 4, 5, and then I'm back to where I started, just on the other end of the line. So there's only 5. So the number of lines of reflection can also be thought of as, with a regular polygon, can be thought of as the number of folds of symmetry. For an odd number, can you just look at that hexagon and you have one in front of you? How many lines of symmetry can you draw with that? Trace the thing out. Trace it on your paper. Are you here? How many lines of symmetry? Check again. Is that right? Is it 6? Is it 3 or is it 6? I'm not sure. You're not ready for that. You're still young enough to take us seriously. Draw them and number them if you need to.
There's 3, there's 5,
There's 6.
there's 6.
There's 6.
That's not 3, my God. There's 5.
So you can go vertex to vertex?
Yeah.
Classes are on right. That's a simple one for itself.
Hayden,
Okay, well then there's 4.
7.
There's 6.
There's 7.
6, guys.
There's 7.
Draw from corner to corner and you'll get 6.
There's 7.
You're on my side.
Eight.
As long as you're not.
Three.
Or stuff like that, that's okay. How many do you have, Ryan? Riley? How many do you have? How many lines of symmetry? You have 3. You have 6. Are you double counting? Because 6 is twice 3, isn't it?
No, because then you can do in between those lines that you drew on there.
Yeah, you can do halves.
Okay. Jada,
Honestly, there's a lot. I can't even do them.
Yeah, because you can do them in halves. Keep doing them in
Yeah, you can
halves.
cut it right to the dead thing. You can cut it.
so you cut it like this. Is that right?
Yeah.
Yes.
Okay.
Yeah, and then you can cut those in half.
If you cut those in half,
Oh,
I
yeah,
don't
never
think you'll have symmetry any longer. If you were to look at this triangle here, that's a right triangle, so we can't go halfway and split that in half. But when you drew the red, when I have my red lines drawn up there, I made isosceles triangles, and those can be cut in half like this. So we have 1, 2, 3, 4, 5, 6. How many lines of symmetry? 6. How many folds of rotation? Center, please, up here. How many lines of symmetry? How many folds of rotation? 6. So here's an octagon, yes? How many folds of rotation?
8.
Okay, now, let's back up. Extend ourselves to this. I had you measure these angles, and I saw some people had like 30-something, 37, 35. Here's what I'd like you to do now. I would like you to find your line of symmetry and pick out pieces of it so that you are going from the center to the vertex. And I'd like you to measure this angle. So if this is your center, you go to the vertex, and I'd like you to measure
Back
that
on the
angle.
pentagon, guys, not on the hexagon.
Yeah, pentagon,
So it's the
pentagon.
pentagon,
Yeah, we'll eventually get them
not
all.
the hexagon.
Look at you, you're good. Oh, that's cool
So
what
what's
you're
the
doing.
measure of the angle of
What you
two
see.
on the pentagon? From vertex to vertex.
Yes, so the line that goes from vertex to vertex, measure the angle. The central angle that goes out of the center.
I mean, but
Vertex to vertex.
there's human error in mine.
Vertex. See my drawing up here, that's got the purple line on it, on the pentagon?
Body,
Let's just wrap it.
protractor.
Vertex to
Measure your
vertex.
protractor?
Use that word.
Human
It's
error.
got a corner like this, right?
Phone a friend.
On a pentagon or a hexagon?
Are you looking at the vertex of the point?
What did you get?
What'd you get?
I got 75 times 1.
I got 72.
That's
You get 7?
Yeah, are you doubting yourself?
What?
72.
What did you get?
What should it equal?
Oh, you need one. Didn't I give you one? Yeah, where is it?
How much is it on there?
You're 72. They don't have this to prove it.
You get a problem solved, so you gotta get a problem solved. It's like, oh, it doesn't, you don't have a water bottle, there's a spring,
What's
there's
the
a water
measurement of the
bottle,
vertex
you
to vertex on there?
Go to 7-Eleven and buy a water bottle, go back to the spring, fill it up, and then walk the 10 miles.
Huh? Why didn't you just lay it home?
I think I'm wrong, but whatever.
Okay. Could I have you guys refocus up here, please? Eyes. Okay, for the pentagon, would you one at a time tell me the measurements that you were coming up with, Phoenix?
I got 72 degrees.
72, TJ?
72.
72? 73? Listen, I don't want to have to ask questions twice. If I ask you to recenter up here, refocus, I want you to be listening. So listen, yes? 70. Okay, so I got some 72, 73, some 70. Here's what I'd like to do. If you go in a complete circle, so in other words, if I was up here pointing at number 1, and I rotated all the way around, how far would my pentagon have rotated? 360 degrees. How many times would it stop with the same shape? So in other words, how many folds of rotation? 1, 2, 3, 4, 5. So each turn is 1/5 of a circle. What's 360 divided by 5?
72.
72.
This is last night's homework.
Yeah, it is. But not everyone was seeing that. A lot of you had questions about it. So in this case here, your smallest turn is how many degrees?
72.
72.
5.
How many folds of symmetry for the hexagon?
6, 60 degrees.
360 divided by 6. Octagon.
45.
45 degrees.
Yeah, I got 45 degrees.
So with an octagon, oh, I don't have an octagon to it. I thought I did.
You can make one with all the colors.
I could, couldn't I? I'd be here all day. But with an octagon, there were how many folds?
8.
8. So that's 4 twice. So the 360 divided into 4 is 90. Divide that again, and it's 45. Okay. I'm sorry?
Is that the measure of the smallest turn?
Yeah, the smallest turn, because 72 plus 72 5 times adds up to 360. Here, 60 plus 60 6 times adds up to 360. And 45 plus 45 8 times is 360. How are we out of here? 35? Yes.
So you're saying like 45 plus 45 times whatever, I don't get what that like plus is.
Okay, can you bear with me on this? 1, 2, 3. 1, 2, 3. This is my best shot at a regular octagon, which is this figure. I can't draw on this thing straight. You know that this is a pain. If I go to the center of the octagon, and I was to draw this angle going through the two vertices. If you took the octagon and you turned it one time, this side would fit into this place. Everything would move one step. So there are 1, 2, 3, 4, 5, 6, 7, 8 steps to turn that octagon. Just like this hexagon has 1, 2, 3, 4, 5, 6. So with the hexagon, that's 1 out of 6 steps. Here's a second, here's a third, there's a fourth, fifth, and a sixth. So I have 1, 2, 3, 4, 5, 6 angles that all measure the same. So that's where I get the 360 degrees divided by 6, makes one of those 60 degrees. In this case here, that's 1, 2, 3, 4, 5, 6, 7, 8 angles. Therefore, 360 degrees, my whole circle, is divided into 8 equal angles. And that, somebody said, came out to 45 degrees. So when we talk about the least turn or the smallest turn, it ends up being 360 degrees divided by how many angles are made. If I had this triangle here, once, twice, 3 times. So the triangle as it turns is made of these 3 angles which are all equal to one another. What is 360 degrees divided by 3? This ends up being 60 plus 60 6 times. You can let that sit for now. Needs to bake for a night. Did I give you a magic triangle last week?
I love
You're gonna want some magic triangles. Okay. Did I give you this last week? Okay. Here you go. You have the digits 1 through 6. 1, 2, 3, 4, 5, 6. You may use each digit one time only. You have to use all 6 digits. You have to arrange them into the triangle so that each side of the triangle, when added, is the same sum.
Oh.
Before you just say what, think about, every one of you was listening and looking at me. Think about what I said before you just go, what?
Okay, makes sense. Dude, if it all adds up from one side to another, doesn't it? Because when I did the same way for
I don't know, TJ. Find out. Go for it. That's why you got pencil and paper.
Wait, so we have the numbers,
Go
are
for
the
it.
numbers 1 through 6, or we have numbers 1 through 4?
The numbers, the digits 1 through 6,
Okay.
they all get used one time. And they get placed in here in such a way that each side has the same sum.
Got it.
Go. No homework.